So I have told you that you need to copy these things in your Excel sheet. First thing that you need to see is HTMT ratio. So what is the criteria of HTMT ratio? The basic criteria of HTMT ratio is that your values should be, your estimated values should be less than 0.90. 0.90. Your values should be less than 0.90. If the values are less than 0.90, it means that according to HTMT ratio, your discriminant validity and reliability is confirmed here. So we can see here the values of HTMT ratio. If we can see, we need to put here in the diagonal some color like gray. Put a gray color here, put a gray color here, and put a gray color here. So we need to see the values under these tables. So you can see that PEU is showing a value which is less than 0.90. PR is showing a value less than 0.90. So all these values are less than 0.90. You can also see in the second column, all values are less than 0.90. In the same way, all values are less than 0.90, and here also all values are less than 0.90. So we can say that according to HTMT ratio criteria, as the estimated values are less than 0.90, therefore HTMT ratio, as per HTMT ratio, the discriminant validity and reliability is confirmed for our constructs. So you need to copy this table from here, and you need to put it here as a table number 4A, table 4A, because it is the first part of discriminant validity and reliability, that is HTMT ratio. And you just need to place here your table like this. You need to click this. You need to go to the table option, select all borders, and then you need to adjust it as per your previous tables like this. You need to adjust these values so they may look similar in terms of width of other tables. You can select these columns, and you can go to like table design. I think table design. No, you need to go to the layout. Yes, in the layout you have an option, distribute rows and distribute columns. So you need to click distribute columns. So it will make it in even like this. So you need to select from this corner, go to your home key, go to your border setting, go to all borders, no border, and then you need to select the first row, put the bottom border, put the top border here. You need to select the last row of your table and put the bottom border. Now it looks like a APA style table. You can also have some width, the row width like this. So this is HTMT ratio, and it is indicating that the values are less than 0.90. So as per HTMT ratio, our constructs are valid and reliable, or our constructs are showing the external validity and reliability. You can also place the full name of these constructs here. So what is the next thing? Next thing is Forner-Larker criteria. So how we can assess the Forner-Larker criteria? There is an easy way you need to understand here. I need to adjust the values first, then I will let you know how can we decide whether as per the Forner-Larker criteria our validity is confirmed, our reliability is confirmed or not. You need to see the first value. You can bold these values, the first value of every column. You need to bold that value like this. and like this. So in Fornell-Larker criteria, you need to compare the bold value with each value after it in the same column. If we can see that the first value or the bold value in first column is greater than all other values of the same column, it means this construct is discriminantly valid and reliable because it is showing the less correlation with other constructs. So it is a unique construct. In the same way, you are going towards PEU and you need to see whether the other values are less than this number or not. So you can see the other values are less than this number. So we can say that PEU is also discriminantly valid and reliable. You can see the PER. You can compare this with other values, and other values are less than this number. In the same way, you can see PS and the other values are less than this number. So here we can say that as per Forner-Larker criteria, our constructs are discriminantly valid and reliable. You need to copy this table from here and you need to put this table here as a, you can say, table 4B Fornell Larker criterion, and you need to put the table here. Select the table, go to the all border, and then you need to adjust this table first like this. After adjusting, you can make them equal using an option I have previously told you. You just need to select them like this and select these columns and go to the option like layout and select the distribute columns, and it will make them equal in width. Just select this and make it as a Times New Roman, Control B, and now select the table and go to the table option, no border, and then go to select the first row, then go to the table, bottom border, top border, then you need to select the bottom row, and it will look like an APA style table, just like this. You have, you can have uh, the row width like this 1.5. It is reasonable. You can also change the format of your font like Times New Roman. It is most recommended one. So you can apply the same in this, the font style Times New Roman. All right. We have put it the second table of discriminant validity. Now we need table 4C as a cross-loading. So what is the criteria of cross-loading for discriminant validity? Very simple thing you need to understand. You need to select this and you need to select this and color them just like this. So you need to see that the factor should have high value in their part of the constructs like this. I can color them the same color. Yes, like this. So you can see FW1, FW2, FW3, they have the highest value in their own constructs. And you need to see whether these indicators have the highest value with other constructs. So you can see that they are indicating the highest value within their own constructs and lower value within other constructs. So in the same way, you need to see PEU factors. You can provide them different color like this, and you need to see where PEU factor is here. So you can color it, and you can color in front of this table like this. So you need to see that in case of PEU, the factors of PEU having the highest value in their relevant construct, but and in other construct they should have lowest values. So this indicates cross loading. But in case if the factors are showing the lowest value in their own construct and highest value in other constructs, it's mean the cross loading is not there. The discriminant validity is violated under cross loading. In the same way, you can select PR1 to PR4, and you can color them like I can color them like this. I can color the constructs from here, and I need to select in front of them the values like this. So you can see PR1 to PR4, they are having the highest loading values in case of their own constructs, and they have the lowest value in other constructs. So every constructs have highest value by their own indicators. So if their indicators are showing the highest value in other constructs, it means there is an issue of cross loading. In the same way, you can see the PS1 to PS4. You can color it like this. No, like this. I need to select here the PS1, and I need to select the relevant values from here like this. Yes. All right. You can see that in case of PS1, they are showing the highest values in their own constructs, and they are showing lowest value in other constructs. So as per cross loading, the discriminant validity is also confirmed here. All right. So this is how you can apply the concept of cross loading here. You can change the color like, yes, this one. So how can we report this table? Should we provide the colors? No, you should not provide the colors. Color is being provided for your understanding so that you can easily understand what I am going to do here. So what we should do here, you just need to make them bold. Make them bold so that it will be easily highlighted during the output table. You need to bold these values, so it will indicate that these are the highest value which are indicated in their own constructs. So it's mean cross loading is there. The discriminant validity is confirmed. Discriminant validity and reliability is confirmed using the cross loading procedure. So you need to select the table, the whole table, then go to this paint box, fill color, just click this icon and go to no fill. Go to no fill, and it will exclude the color. You just need to copy now this table from here, and you need to put this table here as a cross loading table, and select this table. You need to select all borders, and you need to adjust the table like the other ones that I have adjusted like this. And you need to adjust them in equal width. How can we adjust them? Simply go to layout of your table command and go to the distribute column, and it will adjust them in an equal way. Now just select the values, go to the home button, go to the Times New Roman, and then you can select the table, go to the table, select no border, then you can go here, you need to put from table bottom border, then you need to put from here the top border, and then you need to put here the bottom border. Now it will look like an APA style of cross-loading table. So with this, we have completed the convergent validity. So how many table we have generated? We have generated a lot of table here. We simply have 1, 2, 3, and fourth table. So what part we have completed from here? We have completed basically this part. Now we go to variance inflation factor and model fit indices from the same results. Go to here and you will find collinearity statistic BIF. You just need to click it and you will find the values. It is up to you whether you want to report these values or not. But the criteria is that those values which are less than 5 are considered reliable as per multicollinearity, and those value which have value greater than 5, they are highly correlated with each other. So in this case, the values are high correlated, so we should not report this table. Rather, we should report the model fit table. We need to have some corrections over there. So you need to copy this table, copy to Excel, and go to here, put this table here like this. All right, you need to select them and you need to adjust them like this. So you can copy this table from here and you need to put this table as it is here, and you can make adjustment. I think we need to copy again from here. There is an issue of copying. We can select the format from here like Times New Roman, and we can make this table publishable one here like this, and we can select like this. Yes, you can copy this table right from here and you can put in your Word file, and the table is table 5 model fit indices, and you can put it here. You can select this table and you can adjust its table like this. You can select both columns. You can go to the layout button like this and select distribute column, and you have adjusted your table. So how to interpret this table? Always remember that you need to have an SRMR value less than 0.08. So I may rather include a column here. I can adjust their column like this. We need to readjust this table. We go to the table design. We go to the border. We go to the all border. We can have another column here in order to interpret the results more accurately. We can add the column from here like this, and we can put the word cutoff value because we need to compare these value with each other. The cutoff value is that SMR should be less than 0.08. So a value, if it is less than 0.08 for SRMR, then this value is considered good fit. Similarly, a value close to 0.90, close to 0.90 or greater is considered good for the model fit for NFI. So NFI indicates that this value is somewhat close to 0.90, while the remaining values should have lesser discrepancies. It means DULS, DG, and chi-square. They should have lesser discrepancies between the estimated model and the saturated model. So you can see that DULS indicating 1.467 and the same value is indicated in estimated model. So there is no discrepancy. So this value is accepted. Like DG, they are also showing the similar values. Chi-square, this is also showing the similar values. So this is how we can interpret like this. So you can add another column if you want. Like we can adjust these columns and we can put here another column with the decision, and we can write here good fit and the similar words in other good fit. Yes, so you can make it like a APA style of table. You can go to border, you can select no border, then you can select the first row, go to the border, bottom border, top border, then you select the last row, that is bottom border, and then you can adjust it with the line width, like you can go here and you can select 1.5. Yes, so this is how you can report your model fit table like this, and you can change here the Times New Roman. All right, so what things we have completed as per our model? We have completed the assessment of measurement model. Then now we can go for structural model, where we are going to assess these two things. So because these are the advanced things that I will discuss tomorrow, today I will discuss these two things which are very important. So you just need to go to your graphical output, go to the graphical output like this, and you need to run the SEM procedure. So how can we run the SEM procedure? Go to the edit and go to back. Now go to calculate. You don't need to adjust anything from here. You just need to go to calculate button and go to bootstrapping. This is the option for hypothesis testing and for testing the structural model. While the first option algorithm was used for measurement model assessment, whatever we have done till now, we can assess using PLS SEM algorithm. But what we are doing next, that is hypothesis testing and SEM, that would be available using bootstrapping. So click it, and you will find a number of options here. The only options that you need to change is the amount of result. It is showing the most important faster. You need to change it. You need to have a complete amount of result. So select this one, and then you need to select the basically bias corrected accelerated bootstrap. This option is valid for the analysis of your results. Do not use the percentile bootstrap or studentized bootstrap. Always use bias corrected and accelerated bootstrap. While the remaining options are good, you don't need to change them. select start calculation your model because our exogenous variable, one endogenous variable, so it will a very complex model. We have an abandoned variables, or we may have second order construction of the model. It will take up to 5 to 10 minutes based on the speed of your processor. If it is latest one, if it has a good RAM or good processor and good generation or latest generation, it will take some seconds. But if the processor is slow, or if the speed of your system is slow, it will take a number of minutes, like 5 to 10 minutes. So you need to wait to see a complete results which are required here. So it is going to estimate the model. So you just need to see it is almost complete. Yes. Zero here. These are basically the p-value. These are the p-value because in case of hypothesis testing, we require the p-value. Now, one thing I would like to let you know that you does not require to show your indicators in SEM model. Whenever you are using the measurement model, like this one, whenever you are using the measurement model, you need to show your indicators. But whenever you are using the SEM model, you don't need to show your indicators here. So what we need to show, we can hide these indicators. Just right click over here, and there is an option of hide indicators. So hide your indicators because we does not require the indicators in SEM model. We require the indicators only in our measurement model. So you can hide them, and you can make your model easy to look like this. I can adjust it to make it more convenient for me to interpret. So you can make it more convenient and more attractive in order to validate your study. So how can now interpret these values? So you can see these are the p values. I need the coefficient value also. So here you can see the constructs showing the r square, which is 45.2%. It is showing that financial well-being is influenced by PR, PEU, SE, and PS about 45%. And in the outer model, you are seeing the p-value. You need to make them blank because outer model means the indicators that we have hidden. So we don't need the p-value of our outer model. We need to see the inner model. This is basically the inner model. The path or the lines you are seeing, these are the inner model. So we need to see the p-values as well as the path coefficient. So if I select the path coefficient and p-value, it will indicate you the path value, the coefficient value, as well as p-value. If you are convenient to see the t-value, you can select this option, and it will show you the path coefficient or the coefficient value along with t value. So as you can see in the parenthesis, the t value is greater than 1.96. So all paths are significant. How can we interpret this model? We can say that perceived risk is negatively impacting the financial well-being, or it is decreasing the financial well-being, and the relationship between them is significant. And how it is decreasing? Because the path coefficient is negative. In the same way, if we can see perceived ease of use, it is increasing the financial well-being. The t value is greater than 1.96, and the coefficient value is positive 0.701. In the same way, SC, or convenience, I think SC means was service convenience. So I can conclude here. Just a minute. Yes, I can conclude here that service convenience is enhancing the financial well-being. Its t value is greater than 1.96, and its coefficient value is positive. In the same way, PS. What is PS? PS is basically privacy and security. It is also increasing the financial well-being, having the t value. So it is up to you whether you want to consider this model on the basis of t value, or you want to consider on the basis of p value. So I am convenient with p values, so I can show the p values here. So first thing that you need to do here, you need to export this image. export, and you write here the name because there was already a model with measurement model. So you need to change the name. You can write here SEM model and click save, and it will go directly to there on your required table in the form of picture. So you can upload here the SEM model. Just go to insert, go to pictures, this device, and you need to put this model here. And this is, I think, figure number 3, because we have put it 2 figures previously: figure 1 research model, figure 2 measurement model, and this is the figure 3. This is basically SEM model, figure 3 SEM model. So you can easily interpret this model in the way that I have used right now. Now we have what we have put it. We have put it the SEM model graphical. Now we need to put hypothesis testing table. This is the last one that we need to put here. So what I need to do, I need to go to the path coefficient. You can select this one, and you have a table like this. This is the path coefficient table. You just need to copy this table from here, go to your Excel sheet. You need to put this table here. You can see a number of values here. You can place them like this. Always remember that you need to take the values which are also appearing in your graphical model. Like in my graphical model, PR value is indicated by minus 0.169. So I need to yes, this is, you need to take the first column as a coefficient value. This is coefficient value, this is also coefficient value. These are some standardized value, but you need to take the first column value as a coefficient value, and you need to remove this one because we does not need it. You can simplify the other table. So you can write here the coefficient. You can write here standard deviation. You can write here t values, and you can write here the p values. But this is how this table is generated. Just go to here, Times New Roman, just select and adjust your columns and copy this table from here and put this table here, and this would be table number 6. Table 6, hypothesis testing using SEM. You need to put your table here, and you need to adjust it in the same way as I was doing previously, but you need to add some columns here for your consideration. I will let you know how you can adjust them. You need to adjust a column. For example, you can select it here, and there is a plus sign appearing. You can write here decision. uh, what does it mean by decision? If you have created a hypothesis, and it was a positive hypothesis in your literature review that you have created, and your result also indicating that you have positive finding it means your hypothesis was, let's suppose your hypothesis was basically accepted. Like in my research, I can show you the hypothesis. Sir, when will you taught us high order construct, on which day? Tomorrow I will taught you the high order. Tomorrow. There is less than 1 minute. You can join the meeting, because the last thing I need to conclude here is the interpretation of this model. I need to show you something from here as a part of my hypothesis and how to interpret this model. So please join again for a 20-minute more session. So I need to correctly indicate this, how we can conclude this